In our last lesson of Unit C, arithmetic sequences, we're going to be talking about explicit formulas. Again, this is still from 4-7 in your textbook if you were looking at that. So we've been working with our explicit formulas. We've been looking at the elements of those and being able to know what those are before we do it. We want to be able to explain recursive formulas, use addition, and why explicit formulas use our multiplication. We want to be able to look at that. I can write an explicit formula for arithmetic sequence, translate recursive and explicit forms, so going back and forth, and convert sequences from a linear function, slope, intercept, point, slope, and making those into a sequence with our output. So the vocabulary again. The vocabulary yesterday was the arithmetic sequences, so that's in your notes. Make sure you know that formula. Certain sequences, not all, can be written as an equation with what's called an explicit formula. Explicit formula creates a sequence using n as the number location for each term. Explicit formulas for arithmetic sequences are linear equations, and the domain is the natural or counting numbers. The numbers can be written in slope-intercept or point-slope form. So thinking our slope-intercept, y equals our mx plus b, and point-slope, y equals mx minus x1 plus y1. Now, some of you are doing a great job remembering those. Some of you are kind of forgetting the beginning of the unit. Make sure you keep going back. This is going to be a big test. If you can find an explicit formula for a sequence, you're going to be able to quickly and easily find any term in the sequence simply by replacing the n with the number of the term. You cannot do that with recursive. Recursive, you have to find them in order. You have to find the first one, then the second, and the third, because you're always using the previous term. So explicit's really nice if I want to find the 50th term or the 70th term. You should be able to convert between explicit and recursive formulas for any sequence when we look at it. So arithmetic sequences are linear functions. This table shows an arithmetic sequence. Write an explicit formula for the sequence. So the first thing when we are doing that, these are your steps for writing an explicit formula. Step 1, find the slope. If we are looking at this, so how do we find slope? Remember, slope is our change in y over the change in x. Does it matter which change in y we're looking at? No. So if we want to look at how is our x changing, taking 2 minus 1, then in our numerator we need to take 3 minus a negative 1. So 3 minus a negative 1, that's going to give us a change of 4 over 1, which we can see that each time we are adding 4. If we are looking at that. That is our slope, our common difference, our slope. Now it says pick any point. Well, the easiest one is the first one if we are taking a look at that. So we know our common difference. We want to pick a point. Our first point, 1 comma negative 1. Keeping in mind x and y. Step 3, put the slope and the point into point-slope form of your equation. So use n instead of x, a sub n instead of y. So here is our point-slope form. Y equals m x minus x1 plus y1. They just said use n instead of x. So when we go to our equation, we are going to write a sub n. We're going to use that instead of y. A sub n instead of y equals m is our common difference, right? So slope, we might use d, our common difference. N instead of x, n minus, what was our n1 point? Well, x was x1 and y1. We had 1 plus negative 1. So a sub n is equal to 4 n minus 1 minus 1. This is for n greater than 1. So if we are looking at that, we now want to distribute. So we could stop at this point. This is kind of point-slope form of the equation. If we want to think of getting it in slope-intercept form, a to the n, distributing 4n minus 4 minus 1. Our new equation, a to the n is equal to 4n minus 5. If you think about that, the 0 term, if we go back and put in our 0, the 0 would be negative 5. which makes sense. 0, if we go back 4, is at negative 5. And if I plug in 1, I get negative 1. If I plug in 5, 4 times 5 is 20, minus 5 gives me 15. If I go back to this first equation up here, and I plug in 6, 6 minus 1 is 5, 5 times 4 is going to give me, 5 times 4 gives me 20, minus 1, that gives me my term of 19, so it works. So now that we have the explicit, we want to write recursive. So going back to what we did yesterday, thinking about our first term, and now we want to looking at our common difference. A to the 1 is equal to negative 1, a to the n minus 1, and we are adding 4. So our common difference here is back by itself. Here in the explicit formula, it's with the variable. If you need to pause it as you're going on. As we are graphing, when you graph an equation, arithmetic sequence, we want to compare and contrast these. So this is our linear equation. If we are looking at y equals 4x minus 5, a to the n minus 4n minus 5. Now, when we do a linear equation, going way down to negative 5, that line, the arrows keep going in both directions. Here, we have to start at 1. There is no 0 term. So what is similar about both of these? If you're going to write this down, a linear function, they both have slopes of 4. The sequence has a constant difference of 4, so we call them different things. And they both have that y-intercept of negative 5. They also both have at 1, negative 1, at 1, negative 1. If we are looking at their differences, what are the differences between these two? A linear function is continuous. And if we are looking at so continuous versus when we are talking about a sequence is going to be discrete. Only the natural numbers in our domain. Whereas the functions, when it's a linear function, we have all real numbers. So as another name for arithmetic is linear. If it is not linear, it is not arithmetic. So keep that in mind. It cannot be. You have to have constant addition. So think about, is the equation in slope-intercept form? Do you have variables linear? Means your variables are always to the first power. So variable to the first power is how we determine a linear sequence. And we're going to think about that same thing when we are looking at our arithmetic sequence. So which of these does not describe an arithmetic sequence? And what I want you to do is, if you think it is, I want you to think about, well, what's the rate of change? What's the slope if it is? First one, and to the third, not. Second one, variable to the first power. This is going to be arithmetic because what is our common difference? Common difference should be equal to positive 4. We are adding 4 on each time. Take a look at the next two and decide if you think they're arithmetic or not. Pause the video. If you think they are, tell me the common difference. Yes, should be arithmetic. Yes. This one, common difference, you're adding 2/3 each time. If you replace this with 1, with 2, with 3, you're going to see that they keep going up by 2/3. This last one, common difference, or our slope, is -2. Each time you're going to get 2 less as you are looking at that. And again, if it helps you to list those, you could do that. As you look at that next screen down, it says find the formula for the nth term of a sequence 4, 11, 18, 25. The y-intercept is the same as the 0 term. It's before our first. That term is called the initial value. You can use the initial point when you're writing an equation. So here's the first thing we want to think about. We have the ordered pair 1, 4. We have the ordered pair 2, 11. Second term is 11. Can we tell what our common difference is if we are adding this? So if we are looking at that, our slope, our common difference, should be that we are adding 7. We don't have to subtract our y coordinates over x's. We can just look at that sequence and find that. Since we know that that's our initial, we might want to use this first equation. We could write it as a to the n is equal to 7 times point slope form n minus 1 plus 4. And if you are looking at that equation, you can leave your answer in this form. You want to think about what would the 0 term be going back 7. If we are going back 7, that means that that 0 term should be at negative 3, which is what you'd get when you distribute here. A to the n, 7n minus 7, plus 4 would give us a negative 3. I would take either answer. For most of you, my hint is I would stop at point slope form. This is all you have to do. So what you're going to notice down here for explicit formula, it says for any arithmetic sequence, memorize these, you can pick point slope form, a to the n, common difference, n minus the term number plus the term value, or you can go back and find the 0 term as we did here and use that distributive property and get it back to the slope-intercept form. Both forms work. So we're looking at this problem, and it says in a theater, 6th row has 20 seats. Each row has 2 more seats from the row in front of it. The last row has 64. How many rows were in our concert hall? So here are some of the things that we're thinking about, and we want to try and say, what do we know? Do we know our 0 term? No. Do we know the first row? No. Do we know the 6th? 6th row has 20. Do we know our common difference? 2. We don't know which row, but it's 64. We are trying to find out the answers to these questions. Our 0 one, we're trying to find out what is our, if we are looking at it, our nth row. So we're going to start with what we know. We know 6, 20. We also know the slope, or our common difference, is 2. So the easiest form to write it in is when you know a point and the slope is point slope. Instead of writing y equals, we are going to put a sub n because we're dealing with an explicit formula. We are going to put our slope, or our common difference, n minus the point, the term, plus, so this is kind of like our x1 and y1. So a to the n is equal to 2, n minus 6 plus 20. Use your distributive property. A to the n is equal to 2n. This is going to be a negative 12. Negative 12 plus 20 will give us a plus 8. So if we are looking at this, it says, well, which term is 64? 64 is equal to 2n plus 8. We are now going to subtract 8 from both sides. We should get a solution of 56 is equal to 2n. And if we are solving, we should be able to tell that there are 28 rows. Could you replace the 64 up here in that equation? Yes. But making sure that you're understanding how to write the equation and the different ways it looks. We've got 2 more to practice, and then you will have time for your homework. Write an explicit formula. Keep in mind, the first thing you need to know is you need the common difference or your slope. So what's happening each time? Our common difference slope, 10. Think about the ordered pairs. You could use 1, negative 5. You could use 2, 5. You could use 3, 15. There are many answers for this one. I think the easiest one is usually using the first. Please try and write it right now using the first point, thinking of it as a sub n as your explicit formula. This one is probably easier in point slope than slope intercept. Should be 10 times n minus 1 plus negative 5. As you read this last situation in your notes before you work on your homework, it says a wading pool is filled with 36 inches. That's our 0 depth. That is 0.36. This one, probably instead of point slope, slope-intercept. It drains at 3 inches, a rate of 3 inches per hour. That's our slope. That's our common difference of -3. How much water does it hold in n hours? So if we are looking at this, we can write it two ways. The easiest one is slope-intercept. A to the n minus 3n plus 36. And if you think of if we are looking after 1 hour, you should be at 33. Could you have done the point slope form? Or a to the n is equal to -3 n minus 1 plus 33. And if you would distribute this out, you get this answer. So your homework tonight you are working on, please take a look at those. Remember, the key thing as you do the homework, do a problem, check the answer. Do a problem, check the answer. If you're doing it wrong, you don't want to do a lot of them wrong and have to redo it.